Throughout our history, mankind has attempted to delve into the deep, unending mysteries of the world of vectors. Today, thanks to modern science, we are capable of bringing you these mysteries unraveled. With the tape that we have unearthed, we do believe it is from the mid to late 1990s. With an expert panel, we now bring you the secrets and mysteries of the mysterious world of vectors. Get knocked out! But I get up again. You're never gonna keep me down.
Hey folks, my name is Vectors Are Great.
And my name is Addy Shun. With the help of our trusty Versailles to the power TM White Beret, we're going to teach you about vectors. Are lines with both direction and magnitude.
Vectors are
Vectors allow us to use mathematical principles and apply them to real life. Today, we're going to teach you how to add, subtract, multiply them, and also how to find and determine vectors. Vectors are easy to draw. We just go from the origin to the point given to us, and then we draw a line with an arrow. And there, we have a vector. Now we need to name this vector. I think we'll name it V. Get it? V for vector. Now we're going to define V. So we know that the tail is at the origin, or 0, 0. And we know that the head is at 1, 2. So to find the vector, what we're going to do is head minus tails. And that's easy math, right? We get the vector 1, 2. And there. Oh, are you ready to learn more about vectors? So I introduced you to our vector V, which is 1, 2. Now we're going to talk about how to find the magnitude, which is written like this. What this means is we're going to take x and y and put them under the square root. And square both of them under the square root, and then add them together. We find this to be the square root of 5. Now, we've seen this type of formula before somewhere. I think in the Pythagorean theorem. My associate will talk more about this.
Now we're going to talk about standard unit vectors. Write our vector V, which is 1, 2. In standard unit vectors, it would be 1i plus 2j, because that equals 1 plus 2, which equals 1, 2.
Our unit vector is going to be this vector divided by the square root of 5, which equals that.
Adding these two vectors would be 2 plus 4, which is 6. 3 plus 5, which is 8. And voila, that's your answer. If you're trying to subtract the vectors, subtract them. Okay. Dot product. In this case, you're finding a scalar answer, which means a non-vector answer. To do a dot product multiplication, you take AC plus BD, and that's your answer. Yay.
While the dot product gives us a scalar, the cross product is going to give us another vector. It's important to remember that the cross product is only used when we have a three-dimensional vector. So this is an example of a cross product. So we have the vectors 1, 2, 1 and 2, 1, 1. When we multiply them, we're going to set it up like this, where it's important to remember that I is positive, J is negative, and K is positive when writing it in this equation. And we just go through, find the determinants of each of these, and once we do the math, we arrive at I plus J minus K, which is 1, 1, negative 1. And that's our cross product of this times this.
Now finally today we're going to find the angle between two vectors. The formula is theta equals inverse cosine of the dot product of the two vectors over the multiplication of the two magnitudes. This is the formula every single time. And that is how you find the angle between two vectors. It's very fun. Well, that about wraps up for vectors. Vectors are...
And I'm going to throw a paper airplane at it at an angle of 90 and a magnitude of 5 feet.